Hello everyone, and welcome to our Cent S exam preparation series for physics. In this video, we will solve physics questions step by step. I will explain each question clearly, show you the formulas you need, and walk you through all the answer options so you understand why the correct answer works. Make sure you have your notebook and pen ready, and let's get started with the first question. Let's solve this physics question step by step. A car accelerates uniformly from 10 meters per second to 30 meters per second in 5 seconds. We are asked to find its acceleration. Step 1. Recall the correct formula. When motion has uniform acceleration, we use the kinematic equation. Final velocity equals initial velocity plus acceleration multiplied by time. In simple form, v equals u plus at. Step 2. Identify the given values. Initial velocity u is 10 meters per second. Final velocity v is 30 meters per second. Time t is 5 seconds. We need to find acceleration a. Step 3. Substitute the values into the formula. 30 equals 10 plus a multiplied by 5. Now solve for a. Subtract 10 from both sides. 30 minus 10 equals 20. So we get 20 equals 5a. Now divide both sides by 5. 20 divided by 5 equals 4. So acceleration equals 4 meters per second squared. Step 4, check the options. Option A, 2 meters per second squared, incorrect. Option B, 4 meters per second squared, and C answer correct. Option C, 6 meters per second squared, incorrect. Option D, 8 meters per second squared, incorrect. Option E, 10 meters per second squared, incorrect. Final answer, option B, 4 meters per second squared. Quick exam tip. Whenever a question gives initial velocity, final velocity, and time, the fastest method is to use the formula v equals u plus at. Just substitute the values and solve step by step. Let's solve this physics question number 2 carefully. We are asked, a car travels at 120 kilometers per hour for 15 minutes. How far does it travel? Step 1. Convert speed into compatible units. The car's speed is given in kilometers per hour, but the time is given in minutes. To make the calculation easier, convert speed into kilometers per minute. 120 kilometers per hour divided by 60 minutes equals 2 kilometers per minute. Step 2. Multiply speed by time. Distance equals speed times time. Speed is 2 kilometers per minute, time is 15 minutes. Distance equals 2 times 15, which equals 30 kilometers. Step 3, check the options. Option A, 15 kilometers, incorrect. Option B, 20 kilometers, incorrect. Option C, 30 kilometers, correct. Option D, 45 kilometers, incorrect. Option E, 60 kilometers, incorrect. Final answer, the car travels 30 kilometers, which is option C. Tip for students. When speed and time are in different units, always convert them to matching units before calculating distance. Let's solve this physics question step by step. We are asked, in a uniform circular motion, the period is 0.2 seconds. What is the frequency? Step 1. Recall the relationship between period and frequency. The period, denoted by t, is the time it takes for one complete revolution. The frequency, denoted by f, is the number of complete revolutions per second. The formula connecting them is frequency equals 1 divided by the period, or f equals 1 over t. Step 2. Substitute the given period. The period is given as t equals 0.2 seconds. Substitute into the formula f equals 1 divided by 0.2. Step 3. Calculate the frequency. 1 divided by 0.2 equals 5, so the frequency is 5 Hz. which means the object completes 5 revolutions every second. Step 4, check the options. Option A, 2 Hz, incorrect. Option B, 5 Hz, correct. Option C, 10 Hz, incorrect. Option D, 20 Hz, incorrect. Option E, 50 Hz, incorrect. Final answer. The frequency of the motion is 5 Hz, which is option B. Quick tip for students. Remember, frequency and period are inversely proportional. If the period is small, the frequency is large, and vice versa. Frequency is always measured in hertz, which means revolutions per second. Let's solve this physics measurement question step by step. A length is measured as 5.23 centimeters, with an uncertainty of plus or minus 0.02 centimeters. We are asked to find the relative error. Step 1. Recall the formula. Relative error is calculated using the formula. Relative error equals absolute error divided by measured value, multiplied by 100%. In simple words, relative error equals uncertainty divided by measurement times 100. Step 2. Substitute the given values. The absolute error is 0.02 centimeters. The measured value is 5.23 centimeters. So we calculate 0.02 divided by 5.23. Step 3. Perform the calculation. 0.02 divided by 5.23 equals approximately 0.0038. Now multiply by 100 to convert to percentage. 0.0038 times 100 equals 0.38%. Step 4, check the options. Option A, 0.19%, incorrect. Option B, 0.38%, correct. Option C, 0.52%, incorrect. Option D, 0.76%, incorrect. Option E, 1.04%, incorrect. Final answer. The relative error is approximately 0.38%, which is option B. Quick exam tip. Relative error is always a percentage. Just remember this formula. Uncertainty divided by measured value multiplied by 100. Keep your calculator accurate to at least 4 decimal places before converting to percentage. Let's solve this basic SI units question step by step. The question is, in the SI system, frequency is measured in what unit? Step 1. Understand what frequency means. Frequency tells us how many events occur per second. For example, if something vibrates 5 times in 1 second, its frequency is 5. So frequency is simply the number of cycles or events per second. Step 2. Write the unit mathematically. Since frequency means events per second, its unit is 1 divided by second. In symbols, this is written as 1 over second, or simply per second. Step 3. Identify the SI unit name. The SI unit for 1 over second is called the hertz. 1 hertz means 1 event per second, so 1 hertz equals 1 per second. Step 4. Check the options. Option A, hertz, correct. Option B, meter to the power minus 1, incorrect. That is related to wave number. Option C, meters per second, incorrect. That is speed. Option D, seconds to the power minus 2, incorrect. Option E, seconds, incorrect. That is time, not frequency. Final answer. The SI unit of frequency is hertz, which is option A. Quick exam tip. Whenever you see frequency, think, how many times per second? And remember, per second equals hertz. Let's solve this conceptual physics question about vectors. The question is, which of the following statements about vectors is correct? Step 1. Understand what a vector is. A vector is a physical quantity that has both magnitude and direction. For example, velocity has speed and direction. Force has size and direction. Displacement has distance and direction. This is the key idea to remember. Now let's check each option carefully. Option A. Vectors can only be added if they are parallel. This is incorrect. Vectors can be added even if they are not parallel. We can use methods like the triangle method or parallelogram method to add vectors at any angle, so this statement is false. Option B, vectors are described by magnitude only. This is incorrect. If a quantity has magnitude only and no direction, it is called a scalar, not a vector. Examples of scalars are mass, temperature, and time. So this statement is false. Option C, vectors are physical quantities with direction and magnitude. This matches the definition of a vector exactly. So this statement is correct. Option D, vectors cannot be multiplied. This is incorrect. Vectors can be multiplied using operations like dot product and cross product. So this statement is false. Option E, vectors are always perpendicular. This is incorrect. Vectors can have any angle between them. They are not always perpendicular. So this statement is false. Final answer. The correct statement is option C. Vectors are physical quantities that have both magnitude and direction. Quick exam tip. If the question asks for the definition of a vector, always remember, magnitude plus direction equals vector. Magnitude only equals scalar. Let's solve this physics question step by step. A force of 20 newtons acts on a 5 kilogram mass. We are asked to find the acceleration. Step 1. Recall Newton's second law. Newton's second law states that force equals mass times acceleration, or F equals m times a. To find the acceleration, we rearrange the formula. A equals F over m, where F is the force, m is the mass, and a is the acceleration. Step 2. Substitute the given values. We are given that the force, F, is 20 newtons, and the mass, m, is 5 kilograms. So we substitute into the formula. A equals 20 divided by 5. Step 3. Perform the calculation 20 divided by 5 equals 4 meters per second squared. So the acceleration is 4 meters per second squared. Step 4. Check the options. Option A, 2 meters per second squared, incorrect. Option B, 4 meters per second squared, correct. Option C, 5 meters per second squared, incorrect. Option D, 10 meters per second squared, incorrect. Option E, 20 meters per second squared, incorrect. Final answer. The acceleration is 4 meters per second squared, which is option B. Quick exam tip. Whenever you're asked about force and acceleration, remember, F equals m times a. Rearrange to solve for a. A equals F, divided by m. Let's solve this physics question step by step. A 2 kilogram object falls from a height of 10 meters. We are asked to find the kinetic energy just before it hits the ground. Step 1. Recall the principle of conservation of energy. When an object falls under gravity, its potential energy at the top is converted into kinetic energy just before it hits the ground. The potential energy at the top is given by the formula PE equals m times g times h, where m equals mass, g equals acceleration due to gravity, 9.8 meters per second squared, h equals height. Step 2. Calculate the potential energy at the top. We are given m equals 2 kilograms, g equals 9.8 meters per second squared, h equals 10 meters. Substitute these values into the formula. PE equals 2 times 9.8 times 10 PE equals 196 joules. Step 3. Apply the conservation of energy. By the conservation of energy, all the potential energy at the top gets converted into kinetic energy just before impact, assuming no air resistance. So, the kinetic energy just before hitting the ground is 196 joules. Step 4. Check the options. Option A, 98 joules, incorrect. Option B, 196 joules, correct. Option C, 294 joules, incorrect. Option D, 392 joules, incorrect. Option E, 490 joules, incorrect. Final answer. The kinetic energy just before hitting the ground is 196 joules, which is option B. Quick exam tip. When an object falls freely, its potential energy at the top gets converted into kinetic energy just before impact. Always remember the formula for potential energy. PE equals m times g times h. This helps in solving energy conversion problems quickly. Let's solve this SI units question step by step. We are asked, which of the following is not a fundamental unit in the SI system? Step 1. Recall the fundamental SI units. In the SI system, the fundamental units are the basic units from which all other units can be derived. These include second S for time, meter, M for length, kilogram, kg for mass, ampere, A for electric current, Kelvin, K for temperature, mole, mol for the amount of substance, and candela, CD for luminous intensity. Step 2. Check each option. Let's go through each option one by one. Option A, second, S. The second is a fundamental unit for time in the SI system, so this is a fundamental unit. Option B, meter, M. The meter is a fundamental unit for length in the SI system, so this is a fundamental unit. Option C, kilogram, kilogram. The kilogram is a fundamental unit for mass in the SI system, so this is a fundamental unit. Option D, Newton, Newton. The Newton is a derived unit. It is derived from the fundamental units of mass, kilogram, length, meter, and time, second. The Newton is defined as 1 Newton equals 1 kilogram times meters per second squared. Since it's derived from the basic units, it is not a fundamental unit, so this is the correct answer. Option E, ampere, A. The ampere is a fundamental unit for electric current in the SI system, so this is a fundamental unit. Final answer. The correct answer is option D, Newton, because it is a derived unit, not a fundamental unit. Quick exam tip. Remember, the fundamental units are the building blocks of the SI system. If a unit can be derived from combinations of these, it's not fundamental. For example, Newton comes from kilograms, meters, and seconds, so it's a derived unit. Let's solve this physics question step by step. A ball is thrown vertically upward with an initial speed of 15 meters per second. We are asked to find how long it takes to reach its maximum height. Step 1. Understand the motion at maximum height. At maximum height, the ball momentarily comes to rest before it starts falling back down. This means the final velocity at the maximum height is 0. So, the final velocity. V is 0 meters per second at the highest point. Step 2. Use the kinematic equation. To solve for the time it takes to reach the maximum height, we use the kinematic equation V equals U plus AT, where V is the final velocity, 0 meters per second at maximum height. U is the initial velocity, 15 meters per second. A is the acceleration due to gravity, which is minus 9.8 meters per second squared, negative because gravity acts downward. T is the time taken to reach maximum height. Step 3. Substitute the known values. We know V equals 0 meters per second, U equals 15 meters per second, equals minus 9.8 meters per second squared. Substitute these values into the equation. 0 equals 15 plus minus 9.8 t. This simplifies to 0 equals 15 minus 9.8 t. Step 4, solve for time t. Now solve for 9.8 tons equals 15. Divide both sides by 9.8. T equals 9.8 divided by 15 approximately equals 1.53 seconds. Step 5, check the options. Option A, 0.5 seconds, incorrect. Option B, 1.0 seconds, incorrect. Option C, 1.5 seconds, correct. Option D, 2.0 seconds, incorrect. Option E, 2.5 seconds, incorrect. Final answer. The time taken to reach the maximum height is approximately 1.5 seconds, which is option C. Quick exam tip. When solving vertical motion problems, remember, at maximum height, the final velocity is always 0. Use the kinematic equation. V equals u plus at to find the time. And that's a wrap for today's physics questions. I hope these explanations helped you understand the concepts more clearly and made the problem-solving process easier to follow. If you found this video helpful, don't forget to like, share, and subscribe for more physics problem breakdowns. Thank you so much for watching, and I'll see you in the next video.